So I placed a simple wire over here, a very simple wire with a battery. And let's make sure we all could see the positive side and the negative side of this battery. That's battery positive, and this is battery negative. So I'm not going to talk about what's happening inside the wire, guys. Not going to talk about inside the battery. Only the net effect because of the battery on the wire. I'm going to talk only about that. Okay, so as soon as you make this connection, the first thing that would happen, by the way, all this is all imaginary. We really don't know what happens and all. So based on the observed phenomenon, people give theories. So this is one such theory. So when you connect a battery to a wire, the first thing that happens is an electric field gets established inside the wire. I'm actually giving you the theoretical way that's actually given in your textbooks. All right, yeah. The theoretical way, first thing is the electric field. It gets established inside this wire. So everywhere there will be electric field. So, and in fact, the electric field direction, because of Benjamin Franklin and all, it's in the direction from battery positive to battery negative. That's the direction of electric field. Let's use this green for electric field. So this is the first thing that happens. Not going to draw it anywhere, it's waste of time, but only these three locations. Okay. Now, whenever there is, I want you to remember this sequence of understanding. When you remember the sequence, it's easy to remember. I mean, it's easy to understand, and also when you represent it later on your paper, on your exam, it becomes very easy. Wherever there is a field, there is also a force. Okay, we talk about magnetic field around a bar magnet. Everywhere that field exists because of forces. Every pinpoint location, there are forces. So wherever there is electric field, there will be an electric force, and let's use the term Fe. Electric force, we call it electric force. And in fact, electric force is in the direction of electric field. So I'm going one step back. Maybe some of you joined a little later, but let's see step by step. When a battery is connected to a wire, the first thing that happens is inside the wire, an electric field gets established, and the direction of that electric field is from battery positive to battery negative. And the next thing, wherever there's a field, there's always forces inside that field. And that force, we are calling it as Fe, electric force, because it's because of the electric field. And that electric force is also in the same direction of the electric field. Now, there are lots of charged particles inside this wire. Okay, inside this wire, there are a lot of electrons, the charged particles. And what electric field can do is, if the movable charges are positive charges, then it will push in the same direction. Once again, listen carefully. If the charges, please remember the word if, I'm trying to stress on that. If the charges under consideration are positive charges, then the charges will move in the direction of this electric force. But if the charges are negative charges, they will move in the opposite direction of the electric force. So we already know that all the things that are inside these wires are all electrons, which are negative charges. So all these are electrons. These black things I'm using as electrons. And what happens is, because of this electric force, they start to move in the opposite direction. As we just defined, electric field will be there. It has a particular direction. Electric force also has the same direction. If positive charges exist in that material, then those positive charges will move in the direction of this force. Those positive charges will move in this direction. But if there are negative charges like electrons, they will move in the direction opposite. In fact, they will accelerate. Acceleration means, I mean, obviously, wherever there's a force, there's an acceleration. Newton's second law, if you remember, F is equal to ma. Okay, wherever there is a force, there's an acceleration, and all these electrons are accelerating in the reverse direction. Okay, and everything, all of this is happening only because this battery has established a potential difference at the two corners. Okay, at the positive, I mean the wire corner on this side and the wire corner close to the negative side. At these 2 points, a potential difference was established. This corner we can call as high potential region. High potential means, let's say, imagine this is 2 volts battery. Let's call it 5 volts, our wish. So this is a 5 volt high potential, and this can be 0 volt low potential. Some people prefer it like this. They can place it as plus 2.5 and minus 2.5. Even that is okay, guys. High potential and low potential, even that is also fine. Okay, anything is fine. To simplify, I'm using plus 5 and 0. So this plus 5 and 0, the difference between those two potential is 5. So with that 5 volts of potential difference, all these things are happening. Electric field, electric force, then acceleration of electrons. Everything is happening because of that. Okay. Now, is there any question till now? Because we are going to step a little further in this theory. I want to find out if you have any questions. Otherwise, we'll go a few more steps, 3 or 4 more steps inside. Any questions? Please type it in the chat window, or you can even speak if you want. All right, guys, no questions. So before I move on, quick summary. As soon as you place a battery, in fact, something called potential difference will be established. We'll speak about it more, define it properly. But before that, an electric field gets established in a wire. When there's an electric field, an electric force exists. Electric force accelerates electrons in opposite direction to its direction. If there were positive charges, they would move in the same direction of electric force. Otherwise, negative charges move in the opposite direction. Okay, that's what we discussed till now. Sir, is there negative voltage? I saw on PC power supply. I mean, negative voltage means it's alternating current. Amrit gave me this question. Is there something called negative voltage? Yes, yes, definitely. Alternating current has both positive and negative. If I say 220 volts, it can be positive 220, negative 220 also. So there exists negative voltages also. It's all with the direction. By the way, Amrit or anyone who has this question, it's all with the direction. If voltage change or potential difference is in this direction, then we call it positive. If potential direction difference direction is reverse, then we call it negative. Same goes with current. With charges moving in one direction, if you call it as positive current, if the same charges or other charges move in the reverse direction, we call it as negative current. So everything is with the direction, guys. All right, so let's move further. Now, you already observed this. And in fact, let's imagine, I want to say the length of this wire from this location. That's not a straight line, I know, but please bear with me. Let's say the length of this wire is L. Okay, just this top wire, guys, not the whole copper wire, just this top wire. And we are focusing only on electrons moving from one corner to this corner, from the right side to the left, only along this. So we have a force. Okay, so this is force. We have a displacement of these electrons. Now, if you remember the definition of work, work done is nothing but force into displacement. So work done is Fe into L. Okay, work done is force into displacement, and this is the overall. I mean, let's imagine there are 1,000 electrons. So whatever work we are speaking over here, this work done that we are speaking about the amount of work done on all the 1,000 electrons in this wire. But if I speak about a single electron, then what I have to do is I have to divide work done with charge of that single particle. So work done per charge, okay, W by Q, this is nothing but the potential or potential difference. So we just defined the theoretical way in the textbook. So whenever there is an electric field, there will be a force. Force will cause electrons to accelerate. And after, since electrons are accelerating, on electrons, some sort of work is done. That is the work done to move those electrons. And the definition of work is force into displacement. This is the force, and L is the length of the conductor. And when you divide it by a particular charge, we get the potential difference, guys. Okay. So that's everything related to theory. But I want you to know one more thing before we move on to the practical aspect. I want you to know the practical aspect of this also. The thing is about positive work and negative work. Even in ninth class, you have this work, energy, and all that, right? We talk about positive work when, let's say, this is a particle and this is the force. Because of force, the particle is moving in the same direction. Force direction and particle direction are in the same direction. Then we call it as positive work. So if there were positive charges in this wire, it would have been positive work. But what's happening in this experiment or in this discussion, force direction is like this, but electrons are moving in the opposite direction. When the force is resulting in a reverse direction movement, we call it as negative work. So whatever work done in wires, all that is negative work done. Okay. So that's about potential difference, theoretical aspect. And if you observe this formula, we can define potential difference theoretically. It is the amount of work done, guys. Look at the numerator. It is the amount of work done on a unit charge to move it through a particular distance L. Okay. Or it is the difference in potential between 2 points. Between 2 points, the difference is called the potential difference. But I want you to go through the textbooks again after our discussion and hopefully even before the discussion, guys. Okay, that's very, very important. Now, let's look at the practical aspect. I want you to understand the practical aspect. Let's break it off here. I'll just break it. Okay, let's say I break this wire over here. That wire, I have broken it over there at that particular location. Now, it's like turning off a switch. When you turn off a switch, it's like breaking a wire. Now, this one, at this location, you have 10 volts. We all know 5 volts, for example. At this location, you have 0 volts. And now, just for some time, I want you to imagine that these copper wires, they don't take in any energy. It's an assumption. They don't have anything, they don't require any energy, you can think. So since the wire is broken, this particular location will be 5 volts and this location on the right side will be 0 volts. If the wire is not broken, there's a potential difference. Now, please observe this carefully. From here till here, there is no potential difference, guys. No potential difference. Now, my question is, if there is no potential difference, will the electrons move inside? From this particular point, let's call this point A, this particular location A, and this location is B. Between A and B points, there is no potential difference. When there is no potential difference, do you think electrons will move because of the battery? Does the battery have any effect on the electrons? That's what I'm asking you right now. Answers, guys. If the question is not clear, you can just point that out also. I can also show you this practically. I mean, not practical, but at least you can see this. Now I have this battery here. I have this battery. This is the positive of the battery. And I have a wire. I'm connecting it. I'm leaving it free. I'm not connecting it to the negative. I'm leaving it free. So this is positive with 9 volt. And even this corner has 9 volts because potential difference, there is no difference. If I connect it to this one, then it becomes 0. The potential difference will be 9 minus 0. But since it is not connected anywhere, this whole thing has a constant potential difference. When there is a constant potential difference, will the electrons move in there? Amrit just gave me an answer. What he said, Hasini gave me an answer as no, electrons will not move. So Amrit told me that since it is positive and this metal block has electrons, there will be some movement of the electrons. I definitely agree, Amrit, but there are too few, very little bit of effect actually. But we are talking about the overall thing. When we talk about the overall wire, we can actually confidently say that there is no current supply in this wire or no net movement of electrons. Only few electrons that are affected by this. Let's ignore that specific point actually. Okay, I hope all of you got this point. Only when there is a potential difference, electrons will move. You can have an analogy with this, guys. I mean, you know this. I mean, this is, I can't remove it, but anyway, I can make a hole. I like to pop balloons anyways. So I have this balloon, it has air in it. So my question is about the pressure. So I have outside pressure. Outside the balloon, there's a lot of pressure. And inside the balloon, there is pressure. Which is at high potential or high pressure? Where is this high pressure region? Is it inside the balloon or outside the balloon? High pressure, guys. High pressure is inside the balloon and low pressure is outside the balloon, relatively. Yeah, inside is high pressure, outside is low pressure. So when I pop this balloon, okay, so what happened yesterday, that was fun, right? Not only kids, we can also enjoy that. Yeah, so when I popped that balloon, what happened was air kind of gushed outside. Air gushed outside because there's a pressure difference from outside to inside. As soon as I broken that balloon barrier, that pressure difference was observed and it just moved out. Inside the balloon, there was a constant pressure. So there is no net movement of air. Maybe there's not much movement of air. I mean, effective movement of air. But as soon as they broke that barrier, the balloon, the rubber covering or whatever, there's a pressure difference from outside to inside and air just gushed. So if you want movement of anything, there should be a difference. The same thing goes with mountains. Imagine there's a mountain and there's a lot of water on top. Water flows from top of the mountain to the bottom. That's because of gravity, the potential difference that is created by the gravity, mgh formula from 9th class. So whenever there is a potential difference, any sort of energy difference, material will flow. So that's what is happening. And you might be wondering, whenever your parents would have asked you, maybe not this generation, our generation, we were always, I mean, we had a problem with fuses actually, at least when we were very young. Later on, that issue was not there. Whenever we need to actually change the fuse, a small metal wire, we need to pull it out and have a new wire over there. We were asked to wear rubber slippers actually. The reason is, even if you try to touch a switch right now, I'm touching this 9-volt part and my feet are not touching the ground. I'm not touching the ground at any point. Right now, electrons movement will not be there into my body because the circuit is not closed. This positive is at 9 volts and my entire body is also at 9 volts. Since it's all 9 volts, there is no difference in potential. Electrons will not move and I will never get any shock. Even if I touch it, don't do this. This is just for a theoretical sake. Please don't do it. Even if I touch a live wire, 220 volts wire, without touching the ground, I will not get a shock because there is no potential difference, guys. But with one hand, I touch this. And if I touch my feet to the ground, the 220 volts and electrons start to gush through my body. And when they move through my body, what happens is it kind of deep fries all my internal organs, liver, kidney, and everything actually. Okay. However good your heart is, it will get deep fried because when there's a potential difference, there will be movement of electrons, and those electrons, they try to move through the salt water, salt surfaces of our body. And in the process, there's a lot of heat developed and that will fry out everything possible in that scenario. Okay. So that's the importance of having potential difference in order to supply energy. No potential difference, no energy supply. Think about all this. Let me address the questions that I have. Okay, for insulation from ground, no current flow. Exactly. Amrit answered, no. If you have insulation, like the rubber slippers, electrons will not move around. All right, yes. And Rahul, I don't know why you're typing all this. Try to control yourself.
Sir, it's not me, sir. Someone is giving my name, sir.
Is it? Okay, whoever it is, stop doing it, guys. Okay.
Sir, 2 Rahuls are there in class.
Okay, fine. So it's not just, I know that whoever it is, you're bored, but maybe some other people are really trying hard to focus. You need to appreciate and also respect their individuality, and also try not to like disturb others, guys. Okay, let's move on. Right, that's about potential difference. And I have one more slide. I want to conclude potential difference with this particular slide. So when we are going to do that, I want you to make some assumptions. I'm starting with 10 volts over here. So whatever I'm going to tell you, this is the practical approach, guys. Very, very important. Just follow 1 minute with me on this particular slide. Okay, extremely important. What is the meaning of potential difference practically? That's what I'm talking. Whoever wants to create stuff with electronics and all. So this is the reason. And even when you do experiments, when you try to understand the experiments that we are going to do tomorrow, day after tomorrow, this practical sense is very much required. Okay, so this particular location is 10 volts at the left of the battery, and at the right of the battery it's 0. Now let us imagine this is the silver wire, super silver wire. Silver is the best conductor known right now. And imagine we're actually like it's a superconductive state. That means let's imagine this wire is not absorbing any energy from the battery. It's an assumption. Even this wire will absorb some energy. But let's assume for now. And since it is 10 volts and there is no other energy consumer between, I'm writing this as 10 volts. Okay. Again, at this location, if you observe this particular location, there's no other energy consumer. Again, I'm placing 10 volts over there. Yeah, sure, maybe graphene, true. But still, even for graphene and all, I got an answer from Amrut asking if graphene is good. Yes, graphene is good, but still every material will absorb some sort of energy. So that's why I wanted you to make this assumption of no energy for the wire, okay? So 10 volts, 10 volts, 10 volts. And right now, at this particular point is also 10 volts. All right. Now let's talk about this point, guys. Here, bulb, it's an energy consumer. It will definitely take some energy. Let's assume that this particular bulb only takes, let's say, 2 volts of energy. When it takes 2 volts of energy, the left out is 8 volts, right? That's 8 volts of energy. Here again, it will be 8 volts. Here it will be 8 volts. Here also, it will be 8 volts. Why 8 volts? Simple reason, because that is the amount of energy this bulb is taking so that it could glow. It could convert that energy to light energy. Here it is 8 volts. Now imagine this particular TV will consume some energy. How much energy do you think it will consume? Any guesses? Any guesses, guys? At this point, it is 8 volts. How much energy would this point be? TV consumes more energy than bulb. So how much energy would it be? In fact, okay, I'm still getting message from Rahul to everyone. That's really bad.
Sir, it's not me, sir.
I know it's not you. I'm talking to the person who is doing it, Rahul. Okay. Whoever it is, it's not good. Right. So let's move backwards. This is 0 volts. Since there is no new battery between these 2 points, there's no new battery between this point and this point. So that's why I'm using. If there's a battery, then it might increase. So this is 0. This is 0. And since this is 0, this one also has to be 0. Okay. Now we have been talking about potential difference, right? So here you are getting that that essence of potential difference practically. The potential difference between the two ends of the bulb is 2 volts. 10 volts minus 8 volts, that is 2 volts. So that means battery is consuming 2 volts of energy from the, the bulb is consuming 2 volts of energy from the battery. And what is this television doing? It's 8 volts on the left and 0 volts on the right. So 8 minus 0 is 8 volts. So this television is actually absorbing 8 volts of energy, or in simple terms, the potential difference at the ends of the television is 8 volts. The potential difference between the ends of the bulb is 2 volts. Okay. The sum of the potential difference is actually the energy supplied by this battery. 8 volts plus 2 volts is 10 volts. But in reality, what happens is it is 10 volts. Here it could be 9.99, 9.98 at the top, something like that. There will be a little bit of difference. But we try to simplify by making certain assumptions. So from now on, guys, whenever you hear potential difference, I want your brain to have some information. You can say that Potential difference is the energy consumed by an electrical appliance. Okay. Potential difference is the energy consumed by an electrical appliance. Here it's 2 volts. Here it is 8 volts. Okay. But when you are asked in an exam or any of your slip tests or whatever, then you have to talk about it is the work done on a unit charge to move the charge from location A to location B. That's the theoretical way, and this is the practical way. So potential difference is kind of energy consumed. So these electrical appliances are consuming energy. The difference between those extreme points, energies at the extreme points, is called potential difference. This is a very interesting way to solve many problems. Water I've done over here, 10, 10, 10 and all. It's a very interesting way. Tough problems in series and parallel can be solved with such methods actually. All right. So the next thing, what we are left out in today's topics, not essentially today, whatever we can complete, we'll complete. As I've been telling you, when it comes to learning, you should not hurry at all. Okay. I hope you heard Gandhiji saying, I don't remember the exact words, but what he essentially said is, when you are learning something, live as if you have your entire life for that. When you're learning something, you have your entire life to live. But when you're planning to do something, do it as soon as possible, as if today is the last day. If you're going to die today, you have to finish up all your pending works. But when you're learning, you have to reverse it. Learn as if you have your entire lifetime. That means do it perfectly. That's what Gandhiji told. But anyway, so that's what we are trying to follow. We are going slow to understand everything. So our left out things for today, hopefully, is understanding the battery and electromotive force. So when we do these two topics, we'll be starting with our first activity, Ohm's law. It's a relation between potential difference and electric current. V is for potential difference, I is for electric current. And by the way, the instrument that is used to actually obtain potential difference is called, anyone? What is the instrument that is used to measure potential difference? I got answer from Amrut. Anyone else? What is the name of the instrument? Let me give you guesses. Ammeter, galvanometer. Which among those two? Got answer from Hasini. What is the name of the instrument that is used to measure potential difference? Okay, so I tried to confuse you guys. Ammeter and galvanometer, they're used to measure currents, but voltmeter, it's not volta. Voltameter is again the cell that we spoke about by volt. But anyway, the instrument that is used to measure potential difference is voltmeter, V-O-L-T, voltmeter. Okay, someone is having lots of fun. Maybe after half an hour you can have that fun, but please erase this, whoever it is. We have 10 more minutes. You can spend it over here itself, and after that, you can come back one last time for 15 minutes lecture or 10 minutes lecture. All right, so voltmeter. Now, I brought in that particular point because if I have a voltmeter and if I connect one end of the voltmeter to the left, one end of the voltmeter to the left, and this is the voltmeter, and one end to the right, I will be measuring potential difference for the television. Okay, what it will give me is the value on the left minus value on the right. 8 minus 0 is 0. If I place the voltmeter at the bulb at this point and the other point, then it will give me 10 minus 8, 2 volts. So potential difference is measured with voltmeter. And did I connect that voltmeter in series or parallel? Please observe the sketch on the television.
Parallel.
Yes, that voltmeter is connected in parallel, guys. Why it needs to be connected in parallel? It's very simple, because you're trying to measure the energy difference between these 2 points. If you want to find the difference between these 2 points, it needs to be connected at those 2 points, and such a connection is called parallel connection. But when it comes to electricity, now let's say I want to connect, this is an ammeter, guys. Ammeter is an instrument that is used to measure electric current. Okay. Now, ammeter is connected in series because whatever electrons are flowing in the wire, I want those electrons to travel through the ammeter and back to the battery. Okay. Since I want to know, if you remember, the way we understand electric current is very simple. Guys, electric current, whenever you hear, I wanted you to understand two things. How fast are the electrons moving? How many electrons are moving, if you remember. Okay. So if you want to connect an ammeter to measure electric current in this wire, you have to connect it in series. Why? Because you want the electrons to flow through the ammeter. Okay. So that's the reason. All right. Now it's time to erase whoever did that artistic work. That's not mine, by the way. Please erase it. I'll just check if I have an option of erasing it myself, but please, yeah, good. Someone is doing it. Thank you, thank you. Right. So we had two multiple choice questions addressed. Voltmeters are always connected in parallel and ammeters are always connected in series. So voltmeters are used for measuring potential differences. Ammeters are used for measuring electric currents. Okay. All right. So let's understand the principle of battery. Before we actually do battery, I have few questions, guys. I know some of you are not prepared for this extensive theory. We are doing a lot of theory. The reason is Amir sir did not want you to just think about your 10th class. He wants you to have complete understanding. So he wanted me to address in such a way so that you can actually have confidence on this topic. So bear with me, and some of you are already very interested. I don't have to talk to you about motivating you or something, but others, try your best to focus. We are going slow. But my promise, tomorrow we'll definitely start with our experiments actually. Electricity is such a thing, too much of theory and experiments, they happen relatively quickly actually. Okay, before we start a battery, now I want to discuss, we have like 6 minutes or so in this window. We have to close and I'll have to redo the whole thing. But please observe, let's say I have a container and I have water. The blue thing is water. And I drop some salt, NaCl in there. Sorry guys. Yeah, let's say I'm dropping NaCl in there. When I drop NaCl in there, it dissolves. But will it still remain as NaCl, or do you think it will become ions? Will it ionize? That's my question. Once again, when I drop NaCl salt, our table salt at our home, when we drop it, when we drop sodium chloride in water, it dissolves, and as it dissolves, what do you think happens to NaCl? Will it still remain as NaCl, a compound, or do you think it will divide as Na plus and Cl minus ions? That is my question, guys. I have an answer from Hasini. It says compound. Amrit also has NaCl, will still remain as compound. What about others? You don't have to type in here, at least answer to yourself. Will it be as compounds or will it be as ions? Okay, I think most of you answered. Yeah, I have Samra also answering as compounds. Very good, all of you. I want you to pat your back. Whoever said compounds, please do a shabash to yourself. Do it. Come on, Hasini, everyone. Amrit, shabash yourself. And the answer is, it's ions. It's not compounds, guys. They can't remain as compounds. The mere fact that it's dissolving means the bonds between Na and Cl are broken and ions are formed. Okay. These are, whenever you drop them in water, they become ionic solutions. Yes, Hamsika just typed it, divides as Na plus ions and Cl minus ions. I was just kidding with you, asking you to pat your back so that you'll remember the mistake you just spoke about. Okay, before we move on with this discussion, I have a question from Hamsika. Tomorrow, do we have to maintain any notes for practicals? Definite yes. You have to maintain notes. You'll be writing all those results. Later on, you can plot graphs with those. In fact, I will be plotting the graphs. I will show you graphs with Microsoft Excel. You can do that actually very quickly. So I'll show you the graphs tomorrow when we have those data. But I want you also to write it and later on plot graphs so that you can experience, it becomes easy for your exam preparations in the future. Okay. So as soon as I drop it, I'm moving back to the topic, guys. We have 3 minutes or so. So let's place some, all these are positive. Na plus ions, that's the plus. I'm using red. And for chlorine minus ions, I'm using green. Cl minus ions, I'm using green. All right. So I have another question. Right? So one more question. We already know that positives, positive ions and negative ions, they have this attracting ability, right? Positive charges attract negative charges. So tell me this, do you think this, when you drop sodium chloride in water and you mix it up, it has all these ions, do you think they're attracting each other? Do you think they'll come closer and bond again to form NaCl? That's my question. It's still water. I'm not boiling the water or something. My question is, do you think this Na plus ion attracts this chlorine minus ions and they bond again? Do you think that could happen inside water? That's my question. So Amrit just gave me, yeah, Chandrahasa, she was answering about a previous question. They form ionic bond. Yes, fantastic. Sodium chloride is an ionic bond. And in water, they divide and become Na plus Cl minus ions. And my question was, inside water, do you think this plus and minus again come close to each other? Can they bond each other? Because we know fundamentals. What we know is positive charges get attracted to negative charges. So Amrit just told me that they don't attract each other or they don't come closer. Maybe there's an attraction, but they don't come close to each other and again form the solid NaCl. So why is that? The answer is correct. They don't combine again. But why are they not combining again? Logic and common sense tells us that they should combine. Positive charges should combine negative charges. But why don't they combine? Hasini says that energy is needed to combine. But it's a natural process, right, Hasini? Positive charges getting attracted to negative. It's a natural process. So they don't, Amrit also gave the same answer. They don't have enough energy to bond. In a way, you guys are correct actually, but think of it like this. Our connection could cancel out any second, guys. We need to come back quickly. I'll send a new link. But naturally, positive should come close to negative and attract, but it's not happening. That means there is some other force that is pushing these positives and negatives away. I hope you understand this. Positive charge should come and attract to the negative charge and they combine. But that's not happening with the sodium and chlorine ions because some new